So now ethers are really great for the medical field. So these are used as anesthesia, but because they're super duper flammable, we've gotten away from that. They are super effective though. Okay, so our goal here, we're going to name and draw ethers. So I figured I'd start this with just an example of how an ether is formed. So what an ether looks like, and I always kind of remember this, it looks like a bat. This oxygen breaks the carbon chain. Okay, so how does this even form? It forms from two alcohol groups in a condensation reaction. Okay, so in a condensation reaction, we know that when these combine, it's going to kick out a water molecule. Formula for water is H2O. We see, and only functional groups can combine for this, that if we circle it like this, 2 H's and an O. Ta-da! So that's going to cause this carbon right here, or this bond right here, to jump right onto the extra electrons on that oxygen, and then this very electronegative atom. I did not explain that well, but that's okay. And it's going to form this exact molecule. So basically this gets removed and you draw everything else the way that it was, because this bond has to go somewhere. It's going to jump onto this O, because this O has lost that H. It lost a bond. This lost its bonding partner, so now these guys are bonding partners. So that's this bond right here in yellow is this bond right here in yellow. And this could of course be with longer chains or shorter chains like that. It would look like that, so you can have uneven sides. So that's the basics of where ethers come from. Once this is formed, it's very, very strong, very difficult to break. Okay, so now let's get an example up in here of what this would look like. So CH3, O, CH2, CH3. Okay, so we see this O. It looks different than alcohols because an alcohol would have an OH. And we see that it has a CH3 on one side and CH2 on the other. So it's kind of sandwiched in between these. So we've got a CH3. So I'm going to break my normal pattern and draw the extended structural. Okay, so we know that this O has to be attached to that C in order to fill out the other bonds. This carbon cannot attach to that carbon because all of these bonds have been filled. So this carbon, carbon 2 right here, has to have its own bonds. And it's got CH2, and then this carbon will attach to that one, CH3. So sometimes it's beneficial, especially with something that looks like this, to draw out the extended, and then our skeletal would look like this. Boom. So we got one carbon on this side, 2 carbons on the other side. Okay. So our longest chain here isn't the total. The longest chain is literally the longest chain that's unbroken. So on the right-hand side here, we have 2 carbons. That's our longest chain. On the left-hand side, we have 1 carbon. 1 is less than 2. This is the short chain. And these could be switched in positions. It doesn't matter. But you always start with naming the longest chain first. So our longest chain group's name here is ethyl. And then, so this is like acting like an alkyl group here. So it's ethyl, and then we name the short chain methyl. And then we add in the word ether to denote the functional group. So if we had to draw this, we know that one side would have 2 carbons, second side would have 1 carbon, and it would still be an ether. And so if we drew it like this, it's still the exact same molecule because we've got 2 carbons on one side, 1 carbon on the other. The oxygen breaks the carbon chain. So the longest chain is not 3, it is in fact 2. That's the trickiest part with ethers.